Welcome to Study Loop.
All right, guys, so we're doing problem number 28 of chapter 5 of Chemistry Essential Science. So consider a system of two oppositely charged spheres hanging by strings and separated by the distance r1. You can see this in your textbook. Suppose they are separated to a larger distance, r2, moving them apart. What change in potential energy, if any, occurred in your system? So we have, remember, potential energy is E is equal to K Q1 times Q2 over R. Now, K is a constant, and Q1 and Q2 are also constants. These are the charges of our respective spheres. Now, remember, we can we have one sphere that's positively charged, one sphere that's negatively charged. So this is an attractive interaction. Action. So the further remember this graph with E as a function of R. As we move attractive particles away from each other, the energy is slowly going to increase, then level off at 0. So that means as we increase our R value, we move them further apart. The delta E, the energy of our system, is going to increase and then eventually become 0 when we reach each R equals infinity. Now, this is going to, so as our delta E is, as our E is becoming more positive, it's positive, the delta E is also changing, because remember, delta E you can write as E2 minus E1. So as we're increasing our E2 value, so as we move it apart, our E2 value we can use becomes larger and larger. So E2 is going to be greater than E1. So that means that as we move them further apart, E1 is going to be positive. So from R1 to R2, thus delta E is going to be greater than 0. Now, for part C, what can you say about Q and W for this process? Well, we can't say anything about Q. We're not given any information about the temperature, so Q is unknown. And for work, our work is going to be positive because we are pulling these attractive interactions apart. All right. And we also know that delta E is positive, and remember delta E is equal to Q plus W. So we can determine that work is positive, that work is being done on our system to move these spheres apart.